Moving on into probability. An experiment. An experiment is any activity that has an observable outcome. All right, but then we need to define an outcome. So an outcome is the result of an experiment. An event is any particular outcome or group of outcomes that we're looking at. Now, within the events, we're also going to start discussing a sample space. So a sample space is the set of all possible distinct events that we're looking at in a given context or in a problem. The probability of an event, the probability of an event is the extent to which an event is likely to occur. It is a number between 0 and 1, 0 meaning it's not possible and 1 meaning it's guaranteed to happen. It is measured by the ratio of favorable outcomes. In other words, what we're looking for is we're going to count to the total number of outcomes. All right, a little bit of writing here, but just kind of keep up with it. So the way we measure probability is it's the numerator of our fraction is going to be how many are favorable, how many match what we're wanting, over the denominator is all possible combinations that we could have. Now, probability may be written as a fraction, which is how we're usually going to do it, but then all fractions can be converted to decimals, and all decimals can be converted to percent. So sometimes we discuss it as a fraction decimal or a percent. A probability of 0 means no outcome, it's not possible to happen. Probability of 1 means it's guaranteed it will happen every single time we do it. All right, so probability is determined from an experiment. What are some examples that we could see probability with? A couple examples for us to consider that we'll also look at is maybe rolling a die, because we could look for certain combinations or certain numbers to happen. We could also look at tossing a coin, and we'll do that here in one of our examples. We'll talk about heads or tails. We could look at examples where we're spinning a spinner. We could also look at maybe drawing a card from a deck. And these are just a few examples of different things we could encounter if we're looking at probability. Definitely not an exhaustive list, but just a couple of ideas for us to consider. Next, we're going to go work with a definition for sample space. So a sample space is all possible outcomes of an experiment. All right. It is denoted as, usually this is a capital S, and then we'll do a bracket and another bracket, and we'll fill it in. Okay. And so that will be our full sample space we're looking from. We're going to go create a couple of sample spaces here. First one, we're going to look at rolling a die. So the sample space for rolling a die, well, if we're rolling a normal 6-sided die, the results, the possibilities are 1, 2, 3, 4, 5, or 6. But if we're tossing a coin, the sample space would be what? Well, if we're tossing a coin, usually we look at heads or tails, and I'm just going to abbreviate T for tails and H for heads there. All right. So getting our formal definition here for probability, probability of an event is the favorable outcomes over the total number of possible outcomes. So favorable over total possible. Now, this formula occurs if they are equally likely. That means that each outcome has the same opportunity to occur as every other possible outcome. Moving on into some examples here. The answers on a multiple choice test are A, B, C, and D. Write the sample space for this event. So the sample space is going to be A, B, C, or D. So then part B, what is the probability of guessing the correct answer? So the probability of getting correct, well, let's talk about the denominator. How many possibilities are there? How many options are in our sample space? 4, A, B, C, or D. How many of those are going to be correct? 1 of the 4. So probability of guessing correct is 1/4. Next, the letters of the word Tennessee are each written on an individual card and placed in a hat. Write the sample space for this event. All right, so the sample space we could get for, we would start off, we would write the capital T on a card, and then an E, and then N, N, E, S, S, E, E. So you're like, that's a lot of duplicates. It is, but it does make a difference. In fact, kind of to help us count a little bit, I'm going to go in and put a subscript, and that's our first E. We have our second E, our third E, and a fourth E. And then we have 1, 2 N's, and 1, 2 S's. Don't necessarily have to have those subscripts, but just if you wanted to kind of identify the difference in the E's, S's, or the N's. So following in, what is the probability of getting an E? So when we set it up, remember the denominator is going to be total. If you count up the letters T, E, N, N, E, S, S, E, E, that is 9 letters. How many of those are E's? 4. So the likelihood of drawing a card with an E on it is 4 out of 9. What's the probability of drawing a T? Well, out of the 9, there is only 1 T. Probability of drawing an N, again, the nice part here, denominator stays the same because we're still dealing with, we had 9 different letters that we wrote on cards. 2 are N's, so 2 knights. And again, of the 9, the probability of getting the S is 2 out of 9. So we've done some examples there, multiple choice, writing letters on cards. Next, we're going to go work with an event where we have multiple stages. We're going to work with tossing a coin, but we're not going to toss it once. We're going to toss it 3 times and record the outcome. We'll come in and fill in just a minute that blank, how many total. We're going to go ahead and deal with our first. So we're going to start here, and we're going to toss a coin. So this I'm going to call toss 1. So if we toss a coin, we could either get a head or we could get a tail. And then from here, if we follow this branch out, we're going to get to toss 2. And we could either get a head or a tail with this combination or a head or a tail at this point. Then we move to toss 3. And again, we could either be a head or tail, head or tail, head or tail, head or tail. And if you count our ending points, that's 1, 2, 3, 4, 5, 6, 7, 8. 8 different possible outcomes. Now, I also like to talk about building it sometimes with the chart. So we're going to start with our chart over on this side. And let's start with the idea that we did a toss and everybody was ahead. And that is a possibility. In fact, if you were to trace this route here, that's that possibility. That's that head, head, head. All right, but we also have to consider, what if we didn't get all heads? What if we got 2 heads, and then that would imply the third had to be a tail? This is 2 heads, 1 tail, but how else could we get 2 heads, 1 tail? Well, what if we did head, tail, head, and we put the tail in the middle? Or what if we started with the tail and then did head, head? And so those would all be considered different tosses with 2 heads, 1 tail. And then what if we had 1 head, 2 tails? Well, how else could I arrange it so that we still did combinations where we had 1 head, 2 tail? What if we put tail, head, tail? We put the heads in the middle. Or what if the head came at the end so that we had tail, tail, head? And then the last option would again be that we are all tails. And if you go through, that's 1, 2, 3, 4, 5, 6, 7, 8. Now, the results should all be the same, okay? It's just kind of 2 different ways to build your chart for how we would find the combinations and find out how many options we're working with. All right, so write the sample space for the event. I'm just going to draw arrows and be like, those are our sample spaces. We kind of developed it with our images. All right, what is the probability of having exactly 1 head? All right, so having 1 head, those possibilities, I'm going to get my highlighter and come back up. How many possibilities have one head? So one head occurs here, but then one head also occurs here, and one head occurs here. So out of the 8, 3 of them have one head. Now it kind of goes to reason because we're only dealing with 2 options. It's head or tails, that if we have one head, it implies that there have to be 2 tails. All right, and then what is the probability of having all heads? So to do all heads, that would be our first toss right up here at the beginning, and that would be 1 out of 8. So 1/8 would be all heads. So a little bit there on some examples working with a coin toss as we go through this video.